Hello my dear students, welcome to chemistry classes. Today I am going to start with the next concept of group 15 family, nothing but nitrogen family. Today's concept is anamalous properties of nitrogen, dinitrogen and their preparation of dinitrogen and the physical and chemical properties of dinitrogen and the uses of dinitrogen. Okay, let us start with the first one, anamalous properties of nitrogen. Student, anamalous properties means nitrogen, it shows the different property than the rest of the group 15 family. For example, we can here nitrogen family, nothing but nitrogen, phosphorus, arsenic, antimony, and last one is bismuth. Here, phosphorus, arsenic, antimony, and bismuth, they shows the different property, but nitrogen it shows the different property. Yes, nitrogen it has some different reasons to show their different property. To exhibit different property than the rest of the members of that family is called anamalous property. Okay, to exhibit different property than the rest of the members of group 15 family. So this type of properties are called anamalous property. So let us start with the first one, student. Anamalous properties of nitrogen. Anamalous properties of nitrogen. Anamalous properties of nitrogen. Okay, students. First one, what is meant by anamalous properties? Nitrogen exhibits different properties. So nitrogen is the first member of that family. Equal to group 15 family. Okay, nitrogen exhibits different properties than the rest of the family members. Here, student, nitrogen, it is the first member of that family, like hydrogen or lithium and oxygen and fluorine, like this. Okay, nitrogen is the first member of that family. It shows different properties than the rest of the members. Okay, so this type of properties are called anamalous properties. Okay, this type of properties are called anamalous properties. Means it shows different properties. Means some of the elements in that family they show different properties. Those properties are called anamalous property. So here, student, nitrogen shows anamalous property. Why? Yes, it has because nitrogen it has some reasons. Okay, nitrogen exhibits different properties due to. There are some reasons to show the anamalous property. Those reasons are due to first one nitrogen. Here nitrogen, phosphorus, arsenic, antimony, and last one is bismuth. Okay, here nitrogen it shows the anamalous property. Why? The reasons are due to first reason is small in size, smaller in size. Okay, student, here compared to other members, nitrogen is the smaller in size. And second one, high ionization energy or high ionization enthalpy. High ionization energy and high ionization enthalpy. Okay, due to this reason, nitrogen shows or nitrogen exhibits a different property. One more reason is there. Nitrogen, it is a high electronegative element as compared to other members. High electronegativity of nitrogen. Okay, due to high electronegativity of nitrogen exhibits some different property. Here, nitrogen it is the third most electronegative element in the periodic table. First one fluorine, second one oxygen, third one nitrogen. And student, last one more reason to show and to exhibit different property, that is non-availability of d orbital. Non-availability of d orbitals. Non-availability of d orbitals. So these are the four reasons to exhibit or to show different property than the rest of the family members of group 15. Okay, so these are the reasons. Take them. And students, anomalous properties of nitrogen. Anomalous properties of nitrogen. It is a very important question. In previous year, this question was appeared in your annual examination. Okay, anomalous properties of nitrogen. First one, anomalous property of nitrogen. Nitrogen is diatomic in nature. Nitrogen is diatomic in nature. Means it is a atomicity property. Nitrogen is a diatomic in nature, whereas other members, their atomicity is polyatomic in nature, whereas other members are polyatomic in nature. For example, phosphorus P4. Okay, example P4, phosphorus. So this is polyatomic in nature. Okay, student. Nitrogen is the it has atomicity, that is diatomic in nature, whereas other members are polyatomic in nature. And second one, nitrogen is gaseous in nature. Nitrogen is gaseous in nature due to high bond enthalpy. Nitrogen is a gaseous in nature, whereas other members are solid in nature. Whereas other members are solid in nature. And next anomalous property, that is nitrogen is less reactive. Nitrogen is less reactive as compared to other members of that family. Nothing but group 15 family. Nitrogen is less reactive. Here student, nitrogen it has a less reactive because its bond enthalpy is very high and it is made up of a triple bond. Nitrogen is very less reactive. Its reactivity is very low due to large bond enthalpy or high bond enthalpy. Large bond enthalpy or high bond enthalpy, or N2 means nitrogen is made up of a triple bond, N. Okay, it's made up of N triple bond N. That is why it is a less reactive in nature and as well as it is a gaseous in nature. And student, one more anomalous property, that is nitrogen can form p-pi bonding. P-pi bonding, whereas other family members they exhibit p-pi d-pi bonding. Nitrogen can form a p-pi bonding, but other members can form p-pi and d-pi bonding. Nitrogen can form only p-pi bonding, whereas other members can form a p-pi d-pi bonding. This is the reason nitrogen can form a p-pi d-pi bonding. The reason is due to non-availability of d orbital. Due to non-availability of d orbital, nitrogen can form only p-pi bond. And last one important Anamalous property, nitrogen, it exhibits maximum covalency, that is 4. Nitrogen exhibits maximum covalency, that is 4. Students, here last important property, nitrogen exhibit maximum covalency, that is a 4. Okay, it is also due to the non-availability of d orbitals in a nitrogen. But other family members, phosphorus, arsenic, antimony, and bismuth, they shows the covalency more than 4. Okay, so this is about the Anamalous properties of nitrogen, and very important for your annual examination. First one, nitrogen is a diatomic in nature, and nitrogen is a gaseous in nature. Nitrogen is a less reactive, and nitrogen can form a p-pi bonding, whereas other faculty members can form a p-pi bonding. And last one, nitrogen exhibits a maximum covalence, that is 4, but other members can form more than 4. Okay, stay here. And next one, student, dinitrogen. Next one, dinitrogen. It is also called simply nitrogen. N2. Okay, dinitrogen, or you can say nitrogen simply. Okay, student. Here, first one, preparation of a dinitrogen. Here, student, nitrogen is the first family member of that group 15. Here, first one, nitrogen is produced commercially by the liquefaction and fractional distillation of air. First one, air. It is commercially obtained by liquefaction and fractional distillation of air. So air, it undergo liquefaction or fractional distillation. Fractional distillation. Here, nitrogen gas is removed. Nitrogen gas is removed because its boiling point is 77.2 Kelvin. Okay, nitrogen gas is easily removed or easily obtained because its boiling point is 77.2 Kelvin, and oxygen gas is remained in the fractional distillation column or fractional distillation apparatus because its boiling point is 90 Kelvin. Because oxygen boiling point is 90 Kelvin. Okay, student, this is it. Dinitrogen is obtained commercially by the liquefaction and the fractional distillation of air. Here, air containing oxygen and nitrogen. So here, nitrogen is easily obtained because its boiling point is less as compared to oxygen. Its nitrogen boiling point is 77.2 Kelvin. Oxygen gas remaining in the flask, its boiling point is 90 Kelvin. That is why nitrogen is obtained first. And dinitrogen, it is also obtained in the laboratory processes to obtain the nitrogen. There are so many procedures or so many methods are there to prepare the dinitrogen. In that first one, dinitrogen is obtained. Dinitrogen is obtained by the heating of ammonium chloride. Student, nitrogen is obtained by the heating of ammonium chloride and sodium nitrite. Okay, it is simple laboratory method to prepare dinitrogen. First here, dinitrogen is obtained. How it is obtained? By the heating of ammonium chloride and sodium nitrite. Okay, I will write the reaction. First, dinitrogen is obtained. Okay, the product is dinitrogen, N2. Okay, it is always gaseous in nature. Dinitrogen is obtained by the heating of ammonium chloride and sodium nitrate. Ammonium chloride NH4Cl, aqueous in nature, plus sodium nitrite NaNO2. It is also aqueous in nature. NH4Cl and NaNO2. By the heating, nitrogen will be formed. And the remaining byproducts, here how many hydrogens are there? 4 hydrogens. Means 2H2O. Okay? Liquid form. 2H2O. And what is the linkage to it? Na and Cl. Sodium chloride is the byproduct. Okay, this is the first laboratory preparation of dinitrogen. Ammonium chloride and sodium nitrite. By the heating process, we will get nitrogen and water and the byproduct sodium chloride. In this reaction, nitric oxide and HNO3, nitric oxide and HNO3 are also formed. Okay, in this reaction or during this reaction, NO, nitric oxide or HNO3 are also formed by passing sulfuric acid in potassium dichromate. We can remove this NO and HNO3. Okay, nitric acid and nitric oxide can be removed by passing the H2SO4 gas to the potassium dichromate. Okay, this is the first preparation. And second one more preparation for the preparation of dinitrogen. One more preparation of dinitrogen is dinitrogen. Second preparation of dinitrogen. Dinitrogen can be formed by the thermal decomposition of straight here. Dinitrogen can be formed by the thermal decomposition of ammonium dichromate. Student, here first one, dinitrogen can be formed by the thermal decomposition of ammonium dichromate. Okay, I will write the reaction here. Ammonium dichromate, NH4 twice Cr2O7, like K2Cr2O7. By the thermal decomposition, nothing but heating. By the thermal decomposition, we will get a nitrogen, dinitrogen. N2 plus, how many hydrogens are there? 8 hydrogens, means 4H2O and Cr2O3. So here we get a dinitrogen. These are the two important laboratory preparation of dinitrogen. Next one, properties of dinitrogen. Physical as well as chemical properties. Properties of dinitrogen. Okay, properties of dinitrogen. Here student, properties of dinitrogen. In that first one, nitrogen is non-toxic in nature. Nitrogen is non-toxic in nature because our environmental air containing the 17% nitrogen. Okay, nitrogen is a toxic in nature and it has boiling point, that is 77.2 Kelvin, and freezing point is 63.2 Kelvin. Its freezing point is 63.2 Kelvin. And one more student, nitrogen exhibit two stable isotopic forms. Nitrogen has two stable isotopic forms. They are N14 and N15. They are N14 and N15. These two are the stable isotopic forms. And next one, nitrogen non-toxic nature. It has boiling point 77.2 Kelvin, freezing point 63.2 Kelvin. Nitrogen exhibit two stable isotopic forms. Okay, student. And last one, nitrogen is less reactive. Nitrogen is least reactive in nature. Less or least reactive in nature due to high bond enthalpy. Due to high bond enthalpy. Nitrogen is a less reactive nature. And one more chemical property, that is nitrogen when it reacts with metals. Nitrogen when it reacts with the metals, it gives ionic hydrides. And last one, nitrogen when it reacts with non-metals. Nitrogen when it reacts with non-metals, it gives covalent hydrides. So these are the physical and chemical property of dinitrogen. And we use this study, but here nitrogen is used in the preparation of ammonia and other chemicals like calcium cyanide, okay, and other industrial chemicals like calcium cyanide, and it is also used as a preserve material for the preserve the biological specimens.